Hello, my good friends out there. I remain Dr. D. Jun, your lecturer on chemistry on social media. Please, here after the lectures, do like my videos, also comment, and also follow me. You can also click on my bio and access my link to my YouTube channel. Please subscribe. As you do so, God will bless you. What I have to discuss today is titled The Atomic Structure. The atomic structure. As a chemist, you know that we have many different elements, and every element has its own atom. And in our time, when we were in secondary school in the 70s, we defined atom as the smallest chemically and indivisible particle of an element that can take part in a chemical reaction. But these days, it is defined as the smallest particle of an element that can take part in a chemical reaction. That word indivisible no longer is applicable. Why? Because atom itself is made up of smaller particles. And therefore, if that is the case, it is no longer the indivisible. So, atom itself is made up of three basic particles. These are protons, electrons, and neutrons. Now, every atom of every element is having a structure. There is a general structure of atoms. And this general structure of atoms is what I want to discuss right away. In the center of an atom, there is a structure called the nucleus. See it here, nucleus. Now, this nucleus is being surrounded or guided by circular structures or circular substances, which we call shell or orbitals. Now, these orbitals or shells that are surrounding the nucleus are being occupied by electrons. Now, protons are positively charged particles. Electrons are negatively charged particles. Neutrons have no charges. In the ground state, the number of protons are always equal to the number of electrons in every given atom. And that is why an atom in the ground state is electrically neutral. Now, atom is no longer indivisible because a neutron can bombard the nucleus of an atom and the nucleus can be broken. For example, uranium 235 can be broken down to two unequal parts. Well, that's not where I'm going. Now, this is just a general structure. This cell or the orbital that is closest to the nucleus is called the K shell. Next to it is the L cell. Next to the L cell is the M cell. Next to the M cell is the N cell. Next to the N cell is the O shell, and so forth and so on. Now, these X's you are seeing represent electrons. So, in the center, you have the nucleus. The nucleus is surrounded by shells or orbitals. The orbitals are occupied by electrons, which are negatively charged particles. Now, considering the first 20 elements in the periodic table, hydrogen has only one electron, and that electron occupies the K shell. The second element is helium. Helium has two electrons. Those two electrons also occupy the K shell. The third element is lithium. Lithium has three electrons, so two electrons in the K shell and one in the L shell. So the configuration of elements are derived by successfully adding electrons to the outermost lowest available unfilled shell. So the number of electrons in the outermost shell is called the valence shell, is the same for the elements of the same group. So, having said so, let us consider the structure of some elements, like the sodium atom. Now, before you can successfully construct the structure of an atom, you must know the following. One, name and symbol of the element in question. Two, the atomic number of the said element. Three, the number of protons, electrons, and neutrons of the element. And four, the atomic mass of the element. Note also that the atomic number is always equal to the number of protons. And the number of protons are always equal to the number of electrons. And the number of neutrons of the atom can be obtained by deducting the number of protons from the atomic mass. So let us now see the atomic structure of sodium atom and others. Look at it now, this sodium. Symbol of the element Na. Atomic number 11. Number of protons 11. Number of electrons 11. Atomic mass 23. Number of neutrons 23, which is atomic mass, minus 11, 12. Now look at the structure here. This is the nucleus in the center. The P here stands for protons. The N stands for neutrons. The number of neutrons and the protons constitute the atomic mass of the atom. So now the first shell, the K cell, contains maximum of 2 electrons. As you see, I've seen the 2 X's here. Then the second cell contains a maximum of 8 electrons. 1, 2, 3, 4, 2, 2, 8. The only electron that's left is on the third shell here. So the configuration, which is the arrangement of the electrons on the cells of atom, is now 281 in the case of sodium. Now let's take example of calcium. Symbol of the element is capital A, small a. Atomic number is 20. Number of protons 20. Number of electrons 20. Atomic mass 40. So neutrons will be 40 minus 20 is 20. So now coming to the structure, the first shell, the K shell, contains 2 electrons. The L cell 8 electrons. Because the third shell cannot contain more than 8 because the number of electrons left are less than 18. So you take another 8 and then we have 2. So the configuration of this is now 2882. 2882, 20. So we can also use this as a formula or as a method to construct the atom of orders. So please like it, then subscribe to my YouTube